Okay. Hi. So I see that there is some people, well, maybe two people on the stream right now on YouTube. I'm not sure. Yeah. So if you switch to Zoom, we can kind of talk live as well, if you like. So the plan for today is to just do the lab 7 thing. So I will do the debugging first. So what we want to do is we want to make a function that takes in a string and produces an infinite loop if it gets a particular input. So, so sorry, just one sec. So the way it would go is, sorry, I'm not sharing, am I? So something like this. And then we want to check whether course is calculus. And if it is, we want to say, you know, something like this. So just do an infinite. So the simplest possible infinite loop is just something like this. And then else, we just return something else. So for example, delta. So if I run this, like this, that just returns delta. If I print it, we'll print delta as well. On the other hand, if I do say calculus, it's going to be like this. It's going to be just an infinite loop. Okay. So I can interrupt it. So I'm pressing Control I on my keyboard and I'm going to postmortem. So I might need to go back to here. So we're over here. The reason we went kind of deep into the stack is that the function print was being called as I interrupted. So it was printing epsilon. It was about to print another epsilon. So we are over here. Okay. So the handout says, okay, so we're just here and here. Hopefully I'll see, okay, this seems like an infinite loop. So I'll just fix it to be not an infinite loop. So I'll say, I know. So one way to say it is like return epsilon actually. So that would fix it because that would print epsilon the once. And then right away it says return. So return means I go out of the function and I'm done. So that would be like this. So the reason it printed epsilon twice is it printed this and then it said return epsilon. So the value of this was epsilon. So, okay. So here I would try gomoku.py. So I'm over here. And now what I want to do is have some kind of test case. So here are some of the test cases. So I'll just call test detect row, for example. and that produces an error. So that's like one way to fail a test case is you just have an error. So I can say, okay, postmortem again. So I'm in detect row. Sometimes if I go like this, it'll tell me where I am. Not this time, so I'll just look for detect row. So I'm over here, and indeed here I am on line 20. It shows here that I'm returning open sequence count, semi-open sequence count, and it says open sequence count not defined. So this is this, and it's true, it's not defined because this function is not written yet. So if I want to kind of make progress here, what I would say is, okay, so I'll return 0, 0, something, right? So now the test case just failed, so it did crash, and it failed because there was actually a sequence here that was of length 3. Okay, so let me debug it. So this is the first test case. The way I would debug it is I would put a breakpoint here, step in. I'm in test detect row. I'm over here. So what's going on here? So we're saying put sequence on board and print board. So that put the sequence on the board and it printed the board. And now we are in detect row, and we're saying this should be 1, 0. So I can check what detect row returns right now. It's 0, 0. And I can see that it's supposed to be 1, 0. I can step in. Unfortunately, it doesn't work that well always. So here, it's over here, and I see that that's the problem. So it returns 0, 0, and it's not supposed to return 0, 0. At that point, the debugging is just saying, okay, now I got to write the correct version of detect row. So that's that. So I will now do the second part. So that's Gaussian elimination. So the first part is to download numpy.py, rather use numpy.py. And here, essentially what's going on. So let me just copy it. So that would just not copy. So essentially what's going on here. So we're saying, the list of, so a matrix can be represented as a list of lists like this. All we're doing is we're just saying, if you let M be a numpy array, then when you print it, it's going to print nicely as a matrix because numpy knows how to do that. Here you have, an example of matrix multiplication, whatever. You can convert M back to a list of list representation like so. So that's a list of lists now. All that we are doing in this assignment really is we are using NumPy in order to print. So, okay. So let's now go into the actual handout. So what we want is we want the leading index in the row. So return the index of the first non-zero element of row. So let me set up matrix that I'm going to be using. Okay. Something like this is good enough for now. And the name is get lead end. So this is just throw the first index of the first non-zero element. And the function should return length of row if the row contains no non-zero elements. Okay. So what we're doing is we're saying is row at 0 non-zero, is row at 1 non-zero, is row at 2 non-zero, and so on, right? So and if we haven't returned, we say return length of row. So that's pretty much it. At this point, we can test it. So I'll say get lead index. I'm at 0. So what should it be? It should be 0 because the first non-zero element is just the one that corresponds to the 4. So that's 0. And then if I try I'm at 1, that should be 1 because the index of the first non-zero element over here is 1. What happens if I have a row of like 0, 0, zeros? Let me add it here. Here I missed a comma. It's 3. That's the length of the row. So that was this. So, okay. So here we want get row to swap. So we want to take in the matrix M and the integer start I. So this would be the index of the leading coefficient. And we want the row that needs to be swapped with the row sorry, not the index. We're trying to swap with row. Sorry, so not the index of the leading coefficient. This would be the index of the row to be swapped. And we want the row that needs to be swapped with this. So the row that needs to be swapped is the row at an index that's larger than the row. So we're talking 1, it's like one of those guys. And with for itself, which has the leading non-zero coefficient that is as far to the left as possible. So the intuition here is that we want this guy, for example, to be swapped with this guy so that the matrix is kind of more diagonal, essentially. Okay. So we have an example right here. So I'll put it in like so. Comment this guy out. And this is get row to swap. And essentially what we want to do is we want to get the row with the smallest as first I start to the left, leading coefficient index. So okay. So what we'll do is we'll say, okay, so Kerman is going to be the basically the location of the leading coefficient for start I. So this would be get lead end M at start I, and Kerman I going to be start I. And then we'll just try everything else. So I'll say for row I in range, so we start with start I plus 1, and we go up until the last index of the row. So this is length of M. So length of M would be the number of rows. So here, for example, the number of rows is 3. So row I is going to be up to the length minus 1, just 1. And we'll say, so row I, so current is going to be get lead and for row I. And then we'll say, all right, so if current is greater, smaller rather than Kerman, then Kerman is current and Kerman I is row I suppose. And we return row I. Okay, let me test it. So this is get row to swap. And this is, so let's say that I want to swap this guy. So this would be 1, right? And the answer is 3. Makes sense. This is the one that we want to swap with this one. Okay, so add row coefs. So we want to take in rows. So 2 rows, I think R1 and R2. So those are lists. And we have the coefficients C1, C2. And we want basically C1 times R1 plus C2 R2, but as kind of this times this vector plus this times this vector, essentially. So this is a simple for loop. Add rows coefs. So we'll create the answer. So result, like the handout suggests, we start out with 0 times length of C1. It should be R1 C1. Double check. R1 C1, R2 C2. Yes. So this is length of R1. So R is a row. So R1 might be something like this. And then we just go through each row and we add them up. So say for I in range, length R1, result I is equal to C1 times 0 plus C2 times R2 I, of course. And we return results. Okay. So that's the addition. Let's quickly make sure that it works, but I'm pretty sure it does. So we'll say print add rows to Fs. M, does it need M actually? It does not. But this would be, let's say M0 1 plus 2 times M1. Cool. So here we added 2 times 2 plus 8. So that's why this coefficient is 10. All right. So now we're doing eliminate. So it takes in the matrix M. So row to sub is an index of the row to subtract from other rows. And best lead end is the index of the coefficient to be eliminated in the rows that are below. So what's the idea here? So we're saying, for example, if row to sub is 1, so that's this guy, and we are trying to eliminate this and this, what we need to do is we need to subtract 5 times this guy from this guy, and 7 times this guy, rather, from this guy. And that's what we get. Let's do that. So we have M row to sub best lead end. By the way, if you're watching on YouTube, so I'm watching Discord where no one ever asked anything. On Discord, there is also a link to the Zoom if you want to ask a question by video. All right. So what we're saying, let me just copy and paste this guy because that seems like a good example. We have row to sub, best lead end, right? And we're looking at everything below row to sub. So how do we do it? What we want to say is, okay, so for every row below it, so for row I in range row to sub plus 1 up to length of M, and figure out what do we need to multiply this by in order to eliminate this guy. How do we do this? So just this guy divided by this guy, right? So we'll say coefficient is M row I best lead end divided by row to sub best lead end. And now we need to compute this new row. So this new row would be this guy minus coefficient times this guy. So what we're going to do is we're going to say new row is add rows, and we're going to say take the old one. So the old one is just row I and multiply it by 1 and take the 1 at row to sub and multiply it by minus quoth. And that's the new row. And then we're going to say, okay, we've computed the new row. So we'll just change m at row I to be the new row. That is it. Let's see how that works. So we have our example over here. We comment this out. Comment this. So let's see. So row to sub, past lead end, and we're saying eliminate row to sub. So this is just 1 here. And past lead end is 2. And we want to see what m is going to look like. So in order to do that is just convert it to a NumPy array so that it prints nicely. Great, it worked. Okay, so what's going on here? We're saying figure out the coefficient, and then m is just a list of lists, right? So if I say m2 is something else, I can. And the way to think about it is we just may have this function that makes a new row. So we just say m2 used to be this, and now it's going to be something else. So, okay. So that's eliminate. So now we are going to be writing forward step. So that takes an arbitrary matrix M, and it does Gaussian elimination. So essentially, what does Gaussian elimination mean? It means basically apply the things that we've done here repeatedly by calling eliminate on a row that's swapped up so that it has the largest leading coefficient. All right, let's go. So this is going to be forward step. And what we're doing is we're saying swap in the row with the largest leading coefficient, and then eliminate using it, right? Okay, so I'm gonna say for I in range length of m really minus 1, because the last row there is not much that you can do with it. So what do we do every time? We get a row to swap. Get row to swap. And here we're saying m. And we're just saying, okay, so let me rename this to row I. So it's a little bit clearer. So row I. And then we're going to say, okay, we have the row to swap. So once we have it, we just swap row to swap with the current row. So I'll say m row I, m row to swap. is M row to swap. M row I. Right. So what this is doing is it's a situation that's kind of like here, right? Where you want to swap this guy with this guy. So once we've done it, we get the leading coefficient, the index of the leading coefficient. So get lead end. So this is just M at row I, which is now M row to swap. We changed it. And now we eliminate, using that leading coefficient, anything that's below it. Let's say eliminate. M row to sub is row I, and best lead end is lead end. And that is the forward step. So we repeatedly get the row with the leftmost leading coefficient, and we eliminate using it. So let's try it on this. Well, this guy is not really interesting, but let's try it on, let's say, I'll keep this, but copy it. I'm just trying to do something interesting here. Let 8 here or something. Forward step. So let me try to run it just to see what happens, and then we'll print the intermediate steps as well. So what happens is it wasn't happy. So let's try to debug it. So it crashed. So I'll do postmortem. So let me see where the problem is. Line 69. Okay, that's like a boring way to crash. Okay, so that seems to not have worked. Let's see why. So I'll do eliminate, and then every time I do this, what I'll do, like in the handout, I'll print things out. I'll say just swap, and I'll print the matrix. And I'll print the matrix. And I'll print a separate here. And let's say row I is currently this. So let me run this and see what it's doing. So here it says just swapped. So I guess we started with this guy. So we swapped the correct guy and we ran eliminate, and we did eliminate the 8. So that's good. So we've now swapped, and that seems to have gone wrong because it seems like what we really wanted to do was swap this guy and is swapping this guy, and that for some reason didn't happen. So let's see what's going on. I'll put in a breakpoint here. So I'll say, okay, row I is 0, row to swap. Makes sense. So that was actually fine. So now I'm saying row I is 1. So now let me see what's going to happen where, so first of all, I'll print the matrix. So the matrix looks like this. And now I'm asking, what does get row to swap return? It returns 3. Whereas it should be really returning 2. So because I looked ahead of time and I know that it's not going to return the right thing, I want to step in and see why. So I'm in get row to swap. Just confirm what the matrix is. This is the matrix. So what is start I? Start I is 1. And here we're looking for Kerman I, start I. Okay. So I guess the question is, so Kerman here is 2. So Kerman is 2, 0, 1, 2. That's correct. Kerman I is 1, so that's correct. And now we're saying for row I in range start I plus 1. Okay. So row I currently is 2. So we're looking at this guy. And I guess our question is, what is cur? Cur is 1. Aha, so we're returning row I, whereas really what they meant to return was cur min I. What's the problem? So hopefully you see that. Like I was computing cur min I the whole time. Unfortunately, I didn't catch the mistake because row I was maybe the correct answer. Okay, so let's try it now. Success, right? So we've successfully computed a diagonal matrix. So I think from here, what I would suggest is that you do, like if you are struggling with a forward step, I should suggest that you do the backward step yourself. But I guess, yeah, I guess I would suggest doing the backward steps just yourself. I think that would be a good exercise. If there's requests for me to post the backward step, I will do so, but I won't do that in this session.